Can you hear me clearly?
Yes, sir.
Yes, sir.
Okay, Ji. So this was basically the fixed bias configuration circuit. And now we move to the other circuit, which is called the emitter bias configuration circuit. The upgradation of this circuit is something this is called emitter bias configuration circuit. So what we have more or less something similar to the previous circuit which we have just seen. Again, we are providing the input signal over here through C1, and we are getting the output signal from here through C2, right? And now we have, previously the emitter was directly connected to ground, but now in this case we have an emitter resistance RE or this was RB and this was RC over here, right? Again, as we know, we are doing the DC analysis. So this means C1 and C2, they will be taken out of the circuit, right? And once they are being taken out of the circuit, so the circuit will look like this. Are you with me?
Yes, sir.
Right? So
Yes, sir.
as we are doing the DC analysis of this circuit, so this means the C1 and C2, they will be taken out of the circuit. So we are left with this circuit. Once we are left with the circuit, so we can still uh, simplify this circuit further on. By simplifying this circuit further on, I mean to say we will have this, and we can actually write VCC over here, right? And from here we can also see that we have the base current flowing over here, IB, the collected current IC flowing over here, and in the emitter we will have the emitter current IE flowing over here, right? Are you with me?
Yes, sir.
Okay, with this what we can say, we can have the input side. The input side will be taken something like this, and on the input side we can apply the KVL, right? And when we apply KVL to the input side, what we are going to get, if you see, it will become, applying KVL to input side, we are going to get VCC is equal to IB RB
IB.
plus the drop across the base emitter junction, which is VBE, and plus the drop in the emitter leg, which is IE RE. Are you with me?
Yes, sir.
Right? Now, what we know from our previous knowledge, that IE is equal to beta plus 1 times IB, right? IE is equal to beta plus 1 times IB. Are you with me?
Yes, sir.
With this, what we can say, we can replace IE with its corresponding value in the equation. So what we are going to get, we will have VCC is equal to IB.
सर ये बीटा के साथ ये वन किस तरह आया?
Good question. Okay, just hold on. Let me explain this thing then. If you remember, we have IE is equal to IC plus IB. Are you with me?
Yes, sir.
And what we know that IC is equal to beta times IB, right? Are you with me?
Yes, sir.
Now putting the value of IC, which is beta times IB, in the equation IE is equal to IC plus IB. So what we are going to get, IE is equal to beta times IB plus IB, right? So this means IE is actually equal to beta plus 1 times IB.
Yes, sir.
Yes, sir. Clear.
Okay, Ji. Then what we have the equation VCC is equal to IBRB plus VBE plus IERE. So what we do, we replace the value of IE with its corresponding value, right? So when we replace this with its corresponding value, what we are going to get, VCC is equal to IB into RB plus beta plus 1 times RE plus VBE. Are you with me?
Yes, sir.
Right? So replacing the value of IE with its corresponding value, we get this thing. And now if we write the value of IB will become VCC minus VBE divided by RB plus beta plus 1 times RE, right?
Yes, sir.
Are you with me?
Yes, sir.
Similarly, when we take a look for the output side, if we check this circuit, so the circuit is going to be something like this, right? And in this circuit, if we write the equation for this one, it will be for the output side, it will be applying KVL to the output side, right? Applying KVL to the output side, what we are going to get? We will have VCC is equal to ICRC. Then if you see in the circuit, we have a drop in between the collector and the emitter of the circuit. So here we have the base, or here we have the collector. So this means we have a drop in between the collector and the emitter of the circuit, which is VCE, right? And then there will be a drop in the emitter resistance, that will be IE into RE. Are you with me?
Yes, sir.
Okay.
Yes,
So
sir.
when we write the KVL to the output side, it will be VCC is equal to ICRC plus VCE plus IE into RE. Are you with me?
Yes, sir.
As you remember, we said IE is equal to IC plus IB. But as the value of IB is very small as compared to value of IE and IC, so what we normally used to do, that IE is almost equal to IC, right? So what we can do in the equation above, that we can replace the value of IE with IC. So we are going to get VCC is equal to IC RC plus RE plus VCE. Are you with me? Are you with me?
Yes, sir.
Okay. So with this, what we can write, that VCE is equal to VCC minus IC RC plus RE, right? And
Yes, sir.
if we want to write in the form of the straight line equation, so IC is equal to minus VCE divided by RC plus RE plus VCC divided by RC plus RE, right? Now, if we go back to the characteristic curves which we have seen previously, so the characteristic curve and the equation can be, now we have VCE over here, and we have the IC, which are the, again it is the common emitter configuration circuit, uh, and we have the characteristic curve something like this, right? And in the equation, in this equation again, if we put IC is equal to 0, if we put in this equation, if we put IC is equal to 0 in this equation, this means we will get the value. If IC is equal to 0, we will get a value over here, which is VCC over here, 1 point. And if we put the value VCE is equal to 0 in the equation, if we put value VCE is equal to 0 in this equation, so we will get IC is equal to VCC divided by RC plus RE. Are you with me?
Yes, sir.
So,
No, sir.
if we put the value VCE is equal to 0 in the equation, so when the value VCE is equal to 0, this means this will become 0. This part will become 0. Can you see? When VCE is equal to 0 in the equation. When we put VCE is equal to 0 in the equation, so IC will become equal to VCC divided by RC plus RE.
Yes, sir.
Right? So this means we are going to get a point over here as VCC divided by RC plus RE. Right? And this means when we are going to get these 2 points, so what we can do, we can join these 2 points over here, right? When we join these 2 points over here, and if we say this is IBQ over here, so this point where the characteristic curves meets the straight line, we will have the Q point over here. Are you with me? Are you with me? ठीक है जी? So the same thing if
सर आपकी आवाज नहीं आ रही।
okay, now can you listen me?
Yes, sir.
Yes, sir.
Yes, sir. स्लो थोड़ा सा।
Okay, so as you can see that where the characteristic curve meets the straight line, we have the Q point. Again, if the value of VCC is going to vary, so this means the line will be shifted either above the existing line, or the line will be shifted either below the existing line. Similarly, if the value of RC and RE, they are going to vary, so this means the slope of the line is going to vary, right? So the rest of the thing is the same as which we have discussed in the fixed biased configuration circuit, right? Are you with me?
Yes, sir.
Okay, so here comes the assignment. The assignment is example 4.1, example 4.3, and example 4.4, and example 4.5 as well, right?
The assignment.
So the assignment is for today's lecture is example 4.1, 4.3, 4.4 and 4.5. This is the assignment. Right? So that's it for
सर जी पेज नंबर
ये आप बुक में जाके चेक कर लेना, ठीक है जी। बुक भी
Yes,
आपके
sir.
पास है।
Yes,
पेज
sir.
नंबर कम ही हो गया सर बुक
Thank you, sir.
अवार्ड वही
Example 4.1, 4.3, 4.4 and 4.5 they are included in the assignment, right?
एक्सक्यूज मी सर
तो आया
यूनिवर्सिटी खुला हुई तो उसे पता चलेगी सर
यार फिलहाल कोई पता नहीं लगी नोरतासम न्यूज़ और है चेचिसी वाला से वही और चेचिसी वाला से वही अगर शांति बिया बदे यूनिवर्सिटी खुद डिसीजन बई चाहे बिया से कई